Hi, and welcome to this lecture on record linkage. In the following slide, I'll explain you a bit more about what record linkage is and how it can be used in GIS in order to link tabular data to spatial data files. I'll try to explain how linkage is done by using the following small example. Say you have two datasets, one holding the birth certificates of newly born babies, and the other one holding diagnostic data on early hearing defects and interventions. So these two databases contain information on the same set of individuals. So you have, for example, the yellow baby, the brown and the green baby, which occur in both datasets. Equally, you might have the situation where some babies in the birth certificates dataset do not occur in the diagnostic data. For example, the green and the red baby in this example. Now, in the same way, there might be babies which occur in the diagnostic data which are not present in the birth certificates data. For example, here, the pink baby. Now our aim is to find those babies which are present in both datasets. So to find, in other words, the subset of babies in the birth certificates dataset as well as those which match to those in the diagnostic dataset. So how do we do this? Well, matching these two tables, so matching the different entities in both tables is called record linkage. And this is the process of bringing together two or more records relating to the same entity, person, family, event, or hospital. Linkage should be created from any personal data readily available within each of the two datasets. So this requires the release of some confidential information because that allows you to identify individuals within either dataset. This slide shows you a little example of challenges you might encounter. Say you have two tables, table R and table S. Both contain records on individual actors. Here we have Jack Lemmon, Harrison Ford, and Tom Hanks, as well as their social security numbers and their addresses. As you can see, each of these individuals occur in both tables, but based on the different spellings of names, the formatting of the social security numbers, and the formatting of addresses, you might not find direct matches. For example, Jack Lemmon is written with two M's in table R and with one M in table S. Equally, the social security numbers are formatted in a different order, and the addresses are formatted in a way that in one of the tables, streets is abbreviated to ST, while it's fully written in table S. So these type of little differences might pose challenges when you're trying to match records from two tables. So this presents you with the biggest challenge when you're trying to match records from two different tables. Typographical errors and differences in spellings or character uses can lead to mismatches in linkages when you're looking for exact matches. A very famous example is the different ways of how the name Mohammed can be written. It can be written as Mohammed, Mohammed, Muhammad, Mohammed, Mohammed, Mohandas, or Mahatma, which all is equal to Mohammed. This table provides you with an overview of commonly encountered formatting differences which could lead to mismatches where you're trying to match records from two tables. So here you see different ways how names can be written. So it's either lowercase or uppercase. There might be nicknames involved or synonyms. Some data tables might include prefixes or suffixes to a name. Equally, addresses, as seen already, can be abbreviated, or dates, date of birth, for example, can be formatted in different ways. Also, geographic locations can be used to match records, and you can see that different ways of geocodes can lead to various matching difficulties. So overall, you can see that depending on the origin and the quality of your data, there might be quite some challenges when you're trying to merge two data tables. So how should you select different variables to use to match two tables? Well, variables should be selected based on their ability to discriminate between different records. For example, a field with names has greater discriminating power if names are rare. A name like John, which is very common, might not be a very suitable uh, uh, criterion or variable to use to match, as the name John might occur multiple times for different records in two different tables. Variables with high proportions of missing values are also not very useful, as this will lead to mismatches in many instances. Often you see that variables like name, date of birth, or the name of mother and address are commonly used jointly to make a match between two tables. So once these variables have been selected, you have to think about which type of algorithm you want to use to match the records from two different tables. The most commonly used is the deterministic approach. So in this case, record pairs agree or disagree on a given set of identifiers, where agreement on each of these identifiers is assessed as a discrete all or nothing outcome. These are exact matches. This is by far the easiest and quickest linkage strategy, but it ignores the fact that certain identifiers or values have more discriminatory power than others do. Which leads us to the second method, which is probabilistic. Probabilistic record linkage is a statistical estimate of likelihood or odds that two records are from the same individual, even if they disagree on some field. So in order to make a probabilistic match, you'll have to assess the discriminatory power of each identifier and the likelihood that two records are a true match based on whether they agree or disagree on various identifiers used. So what are the different criteria for a unique identifier? So which for the variables you want to use to base the match on. This is specifically relevant for deterministic record linkage. Well, variables selected to make a record match or linkage should be unique. No two people should share the same identifier. They should be universal, so they should be available to every member of the population under study. So every record in your dataset must have a value for that specific variable. They should be permanent, so they should remain unchanged throughout the study period. They should be accurate, so allow for very little mistakes, and they should be reasonable, bring forth no objection to its disclosure if you're, for example, using personal information about individuals. As much as possible, they should be simple to reduce the chance of error, and they should be intuitive to interpret. And of course, they need to be known, so no privacy regulations preventing its availability in either dataset. So once your data has become available, there's a number of pre-processing transformations you could consider in order to improve the linkage process. I will go over a few of them. Firstly, you often find that different punctuation might be present in various data tables. So the removal of commas or other punctuation marks might improve linkage. This is particularly important if the file has to be transformed into a delimited format, such as a comma-separated variable format or CSV file. What often is also seen is that there are hidden, unseen, leading or trailing spaces or unnecessary blanks, which can be removed because they will prevent or will limit your ability to link to records. Correction of upper and lowercase variations. One table might include names all written in capitals, while in others there might only be the first letter might be capitalized. So transforming all of the entries to all capitals or all lowercase might improve linkage. Removal of numbers from variables that should be purely composed of letters and vice versa. So do a checkup on whether you have a numeric field or a date field and it does not contain any other characters other than the dates or letters it's supposed to contain. Removal of accent marks. Different languages use different alphabets, including different accent marks, which might prevent your ability to link records. The removal of terms indicating lack of information, don't knows, unknowns, or unidentified, might occur frequently within a certain column if data is missing. Remove those. Standardization of date formats. Do you write a date with year, month, day, or day, month, year? This might again improve your linkage process. Standardization of these terms in sense of addresses will improve linkage, the same as the order of address elements. And the replacement of various spelling variations with standard spelling of common words and names. So what type of functions do you have to improve record linkage? Well, one thing you could do is parsing, which is partitioning the string into its variable into its components parts. For example, if you have a variable which includes both first, middle, and last name, you can split that up into three different columns, one only containing the first name, one containing the middle name, and the last one just containing the last name. And using these separately, your deterministic will increase the sensitivity of your linkage process. Another pre-processing function is substringing. So it's separating a determined number of characters from a string. So, for example, part of a zip code. Again, this will increase sensitivity. So a trade-off exists between the increase of sensitivity and the undesired consequence in the loss of specificity, because it's much as the more you limit the number of characters, the likely a false match will be made. And you can use different phonetic coding systems, which is coding a string based on how it's pronounced. The SoundX system is a well-known example of this, but I will not go into this further in this presentation. So in summary, record linkage can be said to be a key step in any data management process as well as in GIS. In the current presentation, I refer to records to represent the individuals, but in a GIS, we will often find that each record in a table refers to one spatial unit, for example, a district, a hospital, or a household. So in order to link the information regarding those individuals or a district to its spatial location, a link needs to be made between the attribute values of that individual and the spatial data which we have in our GIS. This linkage can be made based on one or more variables. Unique IDs and deterministic linkage are the most straightforward. If this cannot be done, probabilistic linkage can be considered. Again, we have not elaborated much on probabilistic linkage in this presentation, but there is a lot of documentation on that to be found online. In any linkage process, pre-processing of data will be required to make data formats consistent and to remove errors in advance of the linkage process. Then you have to select a linkage algorithm and always evaluate the result. There is always a chance that there might be false matches or missing matches. If you have a very large data set, you can take a fixed size random sample of records and non-matches to manual review the success of your linkage process. I hope you found this presentation informative. Thank you for watching and bye bye.